Right, welcome once again. In our today's lesson, we are going to talk about circle geometry. Right, so for those who want online lessons, please contact Sam Rewa at this number. You can either WhatsApp me or call me, then we can have our tutorials there. If you have any challenge in any O-level or A-level mathematics, just contact me, then we have our online lesson on Google Meet or on Zoom Meet, right? So today we want to talk about circle geometry. Remember, circle geometry has many theories, so you have to recall all the theories when attempting a question on circle geometry. This question is from ZIMSEC paper, June 2016, paper 1, number 25. So the question reads, in the diagram, points A, B, C, and D. A, B, C, and D are on the circumference of a circle. That means A, B, C, D is a cyclic quadrilateral, right? With center O. That's our O here. With center O. CDS, angle CDS is 50 degrees here. And angle BDO, this angle is 20 degrees. So we have 20 degrees here. Line TS is a tangent to the circle. Line TS, this line is a tangent to the circle at D. Right, so we have about 5 questions here. First question, part A, find D, B, C. DBC from the diagram, DBC. We can have a separate diagram here to show some of the theorems. We can have line TS, which is a tangent to the circle. Let's have line TS, which is a tangent to the circle. Right, under tangents, we have the theorem which states that angles in alternate segment are equal. So here we have a triangle DBC from the tangent DBC and back to D. You can see here we have 50 degrees here. So this angle is also in alternate segment with this angle. So if we have 50 degrees here, this will be 50 degrees from properties of tangents. So angle DBC is in alternate segment DBC with CDS, alternate segment. Alternate segment which is equal to 50 degrees. That's how we answer this angle. Then we move on to part B. Part B, we want DOC. DOC. We want this angle, but we can see that DC is sharing an angle to B and an angle to what? To C, called DC. We can use the theorem, an angle at the center is twice an angle at the remaining part of the circumference. So this angle, if we have 2x here, this one will be x degrees, right? That's the theorem. So here we have 50 degrees. So for DOC, we are going to say 50 times 2. Here we have 50 degrees. So we are going to say 50 degrees times 2. Reason, angles at the center are twice angles at the remaining part of the circumference. Angles at the center are twice angles at the remaining part of the circumference. So this is how we answer this question, which is 100 degrees. Then part C. Part C is saying ODC ODC now, ODC. Remember, we have 100 degrees here, we have 50 degrees here, this whole angle. So ODC, right? We can use properties of tangents again. Property number 1 under tangents states that if we have a tangent, if we have a tangent and a radius, a tangent drawn to the circle is, a tangent to the circle is perpendicular to the radius drawn to the circle to its point of contact. So this tangent is perpendicular to the radius. So again, tangent TS is perpendicular to this radius. So in this case, we have a 90 degrees here. So for ODC, we are going to say 90 minus 50. 90 minus 50, ODC, that's 90 degrees minus 50, and that will give us 40 degrees. Tangent is perpendicular to radius. To radius, right? Or else you can say we have a radius here and a radius here. Since we have now we have 100 degrees here, you can say angles of a triangle add up to 180. So 180 minus 100, that will be 80 degrees. So this one is an isosceles triangle. We are going to divide that 80 degrees into 2 equal parts, 40 here and 40 here. So this angle will be 40 degrees, 40 degrees. We also have 40 degrees. Then part D, ABD, 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 this angle, ABD. Remember, using this theorem, if we have a diameter here, all the angles under a semicircle are right angles. So if we have an angle from the diameter, the end points of the diameter, they meet at the circumference at 90 degrees. So in this case, we have 90 degrees here. So since we have 50 here, we can say 90 minus 50. 90 minus 50, an angle in a semicircle. An angle in a semicircle. That's 90 degrees, which is 40 degrees. Or we can simply say, since we have 40 degrees here, using base AD, angles in same segment are equal. We are using AD subtending angles, angle C and angle B. So 40 will be 40 here also. Then DAC, part E, DAC, DAC, using again angles in same segment. Remember, angles in same segment. We have a base here. This angle is equal to this angle, right? So in this case, we are going to say this angle is equal to this one. Using this one and this one, we are going to say DBC is equal to DAC. Same segment, angles in same segment. So angles in same segment, DBC, remember DBC, we got 50 degrees, which is the same as DAC. Right, so this is how we answer this question. Thank you for watching this video. Remember to subscribe to my YouTube channel, and remember also to share the video. Thank you once again.